Hi everyone, welcome to another Doug's Life video. In this video I'm happy to announce that I've received 2 pounds of sodium metal in the mail. That is an ingot of sodium metal. It's fairly light for its size because sodium has a fairly low density for a metal, and of course it is highly reactive. And that's why it's white, because it's been vacuum packed in this freezer bag, but the plastic is slightly permeable to both oxygen and water over time, and the sodium has reacted with that to form sodium oxide and sodium hydroxide, which is this white coating. So to use for experiments, I need to basically chunk this up and pack those chunks in oil. So I've got here a gallon of just regular mineral oil. That should work just fine. I have a half-gallon jar here, which I'll fill about a little under halfway with mineral oil for throwing the clean chunks in. I have a tray here, a glass tray, which I will fill maybe a centimeter thick of oil, so I can store temporarily the big chunk of sodium in something to prevent it from oxidizing in the air, and I have a safe place to put it while I'm processing the slices that I plan to cut off it. Gloves, of course, because all this white stuff on here is sodium hydroxide and sodium oxide, and unless you're a fan of massive chemical burdens to the hands, you definitely don't want to wear gloves when doing an operation like this. And I also have a second jar, it's off camera, that I will use to store the pieces of sodium metal that come off with the oxide and hydroxide layer, and I'm going to try to recover as much sodium metal from those pieces as possible in a later video. So, without further ado, let's get started. Alright, so I've got all the sodium metal cut. And it's a bit strenuous on the wrist to cut samples that are that large. Usually you can go through them pretty easily with a knife, but it was a bit of effort this time. But I was successful, and I've got these quadrant chunks here in this jar. And you can see there's some small bubbles rising from residual moisture in the oil, but those will subside as soon as the oil dries out. So I have to leave this cap just cracked a little bit, probably overnight, and then we'll be fine. Same thing with this jar. This one has pieces that are more contaminated, but yeah, all in all, that's quite a bit of sodium metal. And I plan to do a lot of cool experiments with that coming up. So I think now it's time to clean up the work area, and then maybe we can play with a little chunk of sodium and see what happens when we react it with water. Like you saw earlier in the video, sodium is a fairly soft metal, so I can cut it pretty easily with just this spatula. In large amounts it's a bit difficult to cut, but in small amounts, as you see here, even with this fairly blunt spatula, I'm pretty easily knocking pieces off. And we'll take a couple of these pieces and add it to water. I got this beaker of water right here, and you can see the reaction of sodium with water to form sodium hydroxide. Put that well away. I'm going to cut this piece in half. So this reaction is quite violent. Move this farther away. So here's the beaker of water, and I'm now going to drop a small piece of sodium into it. And as you can see, the sodium has reacted away. Whoops, not all the way. There it is. It's reacted away to form sodium hydroxide and hydrogen gas. And let's do one more, why not? Anyway, those are the physical properties of sodium and how to cut it and store it and handle it safely. I hope you've enjoyed this video, and I hope you look forward to upcoming videos where I'm going to be using this sodium in many, many experiments. So, thank you very much for watching. Please subscribe, like, and comment.